Okay, now we get to another of my favorite demos. My favorite demos are always ones where we can get the entire room wet or potentially catch anything on fire. So this one involves getting wet. We're going to illustrate Torricelli's theorem that we just derived in our lecture, which was where we said if we have a nice large column of water in a small area hole here, if we fill the water to the top and we open the hole, a faucet or a hole or whatever you want, we will see that the velocity that the water exits the hole will depend on the height of the fluid here. And in fact, mathematically, we show that the velocity is proportional to the square root of the height of the fluid, where if this is the top of the fluid here, down to the hole, that's our h, the height, okay, or y2 minus y1. So what I'm going to do is I'm going to fill this up. I have 3 holes here in my tube. I can open all of them. When I open the first one, though, I want you to notice as the water starts spilling out, right, the height of the fluid will go down, and you'll actually see that the velocity of the fluid starts to go down. It won't go as far before it hits the ground. So we'll do that one first, and then after you see that, I'll pour in some more water and then take out the other 2, so we can see that in fact it's the one on the bottom here which will have the highest velocity coming out because it's got the largest height, and this one will be the medium velocity, and this one will be the smallest velocity. But you can also think about, well, if that's the velocity, can I also predict where will the stream of water hit the ground? Do I know that this one will hit the ground the farthest, or this one, or this one? Or does it actually depend on the height of my bucket? What if I put the bucket up high versus what if I put the bucket down low? Okay, so we'll take a look and see, and then we could work out the math in the lecture notes. So let's take a look. Let's pour in our water. All right, so I'm just going to open one at first, and then we'll just see that as the height comes down, the velocity of the water goes down. So you can see how it's slowly going to start going down, and that where the water stream hits the bucket is slowly going closer and closer toward the column of water. Now we're in here, a little while later, we're here. And of course, when I get down to a height of 0, we'll have 0 velocity, there'll be no more water coming out. Okay? All right, so let's put that back in for a sec. Fill it back up, and then we'll do all 3 at the same time. So Torricelli's theorem said the velocity that it's coming out of the hole should be proportional to the height of the liquid. All right, so ready? This bottom one, this one leaks a lot. If you can see, if you've got me maxed up, you can see it's leaking all over. So let's get this going. Bottom hole, middle hole, top hole. So as you can see, as the height goes down, I constantly have to move that bucket in order to make sure I'm catching all of the water. And again, just as soon as we get to a height of 0, we get no more water. Now, we're going to take a look at the lecture notes and show the answer. Can I predict which one of these will hit the ground the farthest away? Well, if I don't know the distance between my hole and the bucket, I actually can't tell you. it will depend on where I put my bucket. If I put my bucket down here, or if I put my bucket up here, that can change. The streams can actually cross each other there. And we'll work out the algebra in a second to figure out exactly where it should land when it hits the ground, as long as we know the height above the ground. All right,